Good afternoon, guys. How are you guys doing today?
Good.
All right, so today is November the 30th. So your aim today is Kipsters will be able to determine if a function is linear or exponential by a table. You will then be able to create equations from that table for linear and exponential functions, and then you will calculate the rates of change for linear and exponential functions by looking at the table. Are we good with that, guys?
Yes.
Okay, so for our agenda today, we're going to start with the opening activity. Then we'll move on to guided practice. After that, we will move on to independent practice. Are there any questions so far?
No, ma'am.
Okay, so as you guys know, the previous lessons we have been learning about rates of change, linear functions, and exponential functions. So what I need you guys to do right now is to take out your notes from lessons 1 through 6 of Unit 3, talking about linear and exponential functions. So for our opening activity today, guys, what I need you all to do is draw a T-chart, okay, and give me 4 examples of the differences between linear and exponential functions. You have 3 minutes to do it, okay?
All right.
All right. As you guys are brainstorming, I'm going to put my exemplar on the dot cam, and then we can compare our answers and move forward, okay?
All right.
All right. I like the way you guys are taking out your notes, looking at your notes in order to create a T-chart. What you guys also can do is work with your shoulder partner, okay? You and your shoulder partner need to get together and collaborate and come up with 4 differences between linear and exponential functions. You have 2 minutes remaining. You guys have 1 minute remaining. Any questions or concerns?
No, ma'am.
Okay, thank you. Okay, guys, so now what I'm going to do is post my exemplar. And what I want you guys to do is look at your answers and look at my answers. And I want you all to assess whether you're going in the right direction. If you have any inconsistencies, I want you to now turn the page, create a new T-chart, and you need to write the guided notes that I have provided for you guys. Do you need me to zoom in any?
Please.
Would you like the light cut off?
No, ma'am. Thank you.
Alrighty, so as you guys are writing, I'm going to talk over the notes. Okay, would anyone like to share some things that they see here that they have written down on their own papers?
That y equals mx plus b is actually the slope.
Is that for linear or exponential?
Linear.
Good job. Anything else that you all see here that you have already previously written down with your shoulder buddy? Yes.
Fx equals a b powered by x.
Very good. Okay, so what I'm going to do is go ahead and read through the notes with you. As I'm talking again, guys, you all are going to write what I'm saying, or you're going to copy the notes, okay? You can abbreviate if need be. So for our linear functions, we use addition when we're looking at our y values. Okay, we use the formula y is equal to mx plus b. You can also say f of x, like he said, f of x is equal to mx plus b, which is our actual slope-intercept form, okay? We're always increasing or decreasing. The rate of change is constant, meaning it will not change. Our slope is represented by m. Our y-intercept is represented by b. We can also do rise over run when we're looking at a graph. In order to get the rates of change, we use delta y over delta x. Does anybody remember what delta stands for? If not, it's okay. Reference your notes.
Is it the triangle?
It is a triangle, but delta means the change in, okay? So also we can do y2 minus y1 is equal, divided by x2 minus x1. Our graphs will always be increasing or decreasing. And remember, for every output, it has a unique input. And for our linear functions, they can be continuous or discrete. What does it mean to be continuous? continuous.
Keep going.
Keep going. How do we represent continuous in terms of graph? What things indicate that it keeps continuing and going on? Arrows. Very good. And what does it mean to be discrete?
Stop.
Intercovers decrease.
Not decreased, that's a nice guess. They're scattered, okay? The lines are not connected, they're just points plotted, and they do have a stopping point. Very good. So for exponential, I need you all to have that we use multiplication when we're looking at our y values. The formula we use, as he said, is f of x, or y, equals a times b to the exponent of x, where a is our starting point, or when x is 0, it is our value for y. B is our multiplier. And again, this is what we use for our rates of change formula, delta y over delta x. So those are some similarities between the two. These graphs are always continuous, and B can also become 1 plus the rate, which means it's a growth, or 1 minus the rate, which means it's a decay. Our graphs for exponential functions will always look like this. So when x is 0 for my y-intercept, let me rephrase that. X is always 0 for my y-intercept, and y is always 0 for my x-intercept, okay? So now, guys, we're going to do 2 guided practice charts, okay? So what I need you guys to do, am I going too fast?
No, ma'am.
We all good? Thumbs up if we're good. Thumbs down if we're not. Thumbs in the middle if we're a little confused. Okay, all clear for thumbs up. Thank you. So, also, guys, I would like to add in that the big difference that I want you all to notice between linear and exponential, with linear graphs, okay, for the y values, we're using addition. For exponential, we're using multiplication. And another difference is for exponential graphs, we'll always have an exponent. That x represents our input. Do we remember learning that?
Yes.
Okay, thank you guys.
You're welcome.
So what I need you guys to do is to go ahead and copy down this table of your x and y values, and we're going to create an equation from here. Take about 40 seconds to draw your chart, please. Okay, thank you for drawing your chart, guys. So when we look at our x values, can someone please read me my x values?
0, 1, 2, 3, 5.
Thank you. 0, 1, 2, 3, and 5. And can someone please read me my y values?
2,
2,
5.
5, 8, 11, 17.
Very good. Okay, so when we're moving between 2 and 5, how did I tell you guys to figure out what the change is? What do we need to do? To our second value and our first value in order to figure out. Subtract. Very good. So what is 5 minus 2? 3. Okay. So what is 8 minus 5?
3.
What is 11 minus 8?
3.
And what is 17 minus 11?
68.
Try it again. Use your calculators.
6.
Okay, so we see we have 3, 3, and then 6. But are we missing a middle number between 3 and 5?
Yeah.
So it's okay. So we all notice that our change in y is what? 3. Very good. And what is our change in x?
1.
1. Very good. Now, when we were looking at our y values, did we add or did we multiply?
You said we why? Oh, we added.
We added. So if I was to say we added, then would this be considered a linear or an exponential function? Linear. Very good. So these are the notes that I need you to have. I need you to show your work. Okay. You all just gave me the answer. So we're looking for an equation. So we've already established that we have added 3, and then we added 6 at the end. And we just figured out our delta y over delta x. Okay, you all told me that my change in y was 3 and that my change in x was 1. So that gave us 3 over 1. Okay, and then if we look at the end, okay, the change was 6 for y, and it was 2 for x. When we simplify both of these, it gives us 3. So we know that this is a linear equation, okay?
Yes.
Excuse me, a linear function. Now, in order to create an equation, what is the formula that we use in order to write a linear function? It's at the top of this paper if you forgot.
Delta.
What's the formula?
Oh, y equals mx plus b.
Y equals mx plus b. Very good. So, in order to do so, we need to figure out what our m is. What does m represent?
Slope.
Slope. What's another way to say slope? Rise over run, or what else? Starts with the R. Rate of change. Very good. So when we just plug this into our rate of change formula, delta y over delta x, guys, it gave us that our m value was what number?
Three.
3. All right, very good. So in order to figure out our y-intercept, it is when x equals 0. So when x equals 0, what is our value for y? If you look at the table, it tells you look directly under x. What is the value of y? 2. Very good. So it's safe to say that our y-intercept is what? Or our value of b, which represents our y-intercept, is what? 2. Very good. So if I'm plugging this into my formula, y is equal to mx plus b, what do I have? What is my value for m? 3. So I'm going to say y is equal to 3x plus, what was our value of b? 2. So y is equal to 3x plus 2. Do we understand?
Yes.
All right. So let's take a quick look at the next one. Okay? Please write the chart down. So we have 0, 1, 2, 3, and 5. And for our y values, we have 5, 10, 40, and 60. As you can see, we are increasing by 1 for our x values, and then plus 2 for our last one. If we look at our y values, okay, if I subtract 10 minus 5, what do I get?
Okay.
And then when I do 20 minus 10, what do I get? 10. Are those numbers matching? So that lets you know that this cannot be a what type of function? Linear. Very good. It has to be a what function? Exponential. And what do we say that we use when we are doing exponential functions? Another word? Multiplication. Very good. Okay, so then, what's the opposite of multiplication? Division. So I need to divide my second number by my first number. When I do such, what do I get? Meaning, what is 10 divided by 5? Use your calculators, guys. 2. Very good. So, when I do 20 divided by 10, do I get the same number? Is 20 divided by 10 2? Right, so I can say that we're multiplying by what number? 2. Very good. And at the end, we have a big jump like we did over here, but it's okay because we're missing our 4 spot. So again, we do delta y over delta x, okay? What was our change in y? You just told me. 2?
Yes.
And what was our change in x? What's our change in x?
1.
1. And what is 2 divided by 1? 2 divided by 1? 2. Very good. So, now, okay, we know that our formula that we use is f of x, or y equals a times b to the exponent of x, okay? Remember we said a was our what? A is our what, guys? Look at your notes. It starts with the S.
Slope.
No, not slope. That's a nice guess. SP are the initials. Our starting point, guys. It's our starting point. It's when x is 0, what is our value for y? So, when x is 0, what is the value of y? You look directly up under it. When x is 0, what is the value of y? 5. Very good. So y is equal to 5. We just figured out our multiplier. We said 5 times what gives us 10?
2.
2. Thank you. And then we just throw an x up there, okay?
Yes.
That is our equation. So So now what I'm gonna do is show you all the work that has been done. Please take this time to make sure you have the notes written down verbatim. Now what I'm going to do, guys, is come around and give you your independent activity for today, okay? The first 10 minutes of independent practice, I want you to work by yourself to see if you're doing it, to see if you understand it, okay? If you need help, raise your hand and I will come help you. After those first 10 minutes, you guys can work with a partner, and I want you to compare each other's answers, and if someone has something different, I want you to talk through it, okay? Why do you think it's a linear function? Why do you think it's an exponential function? How did you get your answers, okay? That's what I want you guys to do. And I'm gonna set the timer for 10 minutes for you all to do such. Okay, guys, thank you so much for participating in the independent activity. You guys did a great job. I'm very proud of you all for the day. So now what I would like you to do is take out a sheet of paper. On a sheet of paper, I want you to write this question, okay? What are 4 differences between linear and exponential functions, okay? And also, number 4 and number 6 from the independent practice, I want you to put that on your exit ticket as well, okay? Thanks, guys.
No problem.